Welcome back, ladies and gentlemen. This video is because I neglected to do number 23 for the preparation for practice D. D as in dog. So we're going to do just this problem. So it should be pretty fast. Okay, so here it says a tennis player places a machine, 55 kilogram ball machine on a frictionless surface shown below. The machine fires a tennis ball, a 0.057 kilogram tennis ball, horizontally with a velocity of 36 meters per second towards the north. Okay, we know velocity is a vector and gives us direction towards the north. What's the final velocity of the machine? All right, so maybe you've seen these people that are serious tennis players, my sister-in-law and brother-in-law, when they want to just practice responding, let's say, they have a machine on the other side that's just shooting out tennis balls. Boom, boom, boom. These things just keep shooting out tennis balls, okay? And because there's a velocity coming out, there's going to be a reaction. Remember, equal and opposite reaction. So this guy is just standing still, holding all these balls, but because there's a ball that shoots out, this guy is going to move. This is similar to if you guys have been shooting gun and there's a recoil. You're just standing there and the ball, the bullet jumps out of the gun, shoots out of the gun, and there's a recoil. It's going to be pushing you back too. So now you can figure out exactly what the velocity is. All right, so let's look at it again. The machine is 55 kilograms. If I can, let's see, I do my book here. All right, I'm going to fold this up here because I finally made a copy of it instead. All right, so what do I have here? You can meet you go. Bring this way. There we go. All right, so I have the mass of this thing. Let me show you a box here. The mass of this thing is going to be shooting out balls. Okay, the mass of this, we're going to call this mass 1. The mass 1 is 55 kilograms. But then it shoots this ball. So I'm going to call this mass 2. The mass 2. All right, so the mass 2 is the ball. And by the way, the mass 2 is, they gave us, it's, what is it, 0.057 kilograms. So that'd be like 57 grams. Hey, your little rubber ball was about that much, I think. Maybe yours was 85, I don't remember. Okay, 0.057 kilograms. And it comes shooting out at a 36 meters per second. Okay, so this thing, when it comes out, is 36. When it comes out, it's 36 meters per second. So initially it's just sitting inside, right? It's sitting inside of here, so it's not moving. So, okay, so this guy here, final, that would be his final velocity. His initial velocity is nada, zero, zippo, zero, okay? And the mass of this guy, the big guy here, his initial velocity, M1 initial, is 0. So the question is, what's the velocity final of this guy? All right, so this is an example of completely, here we go. We did a problem of this the other way. I don't see it here. Aquí está. Inelastic. There it is, inelastic. Remember, this was you're skating and you pick up a kid and together you're skating together. But instead of this way, it's the other way around, because conservation of momentum doesn't matter which way is initial, which way is final. So here it is, the box with all the tennis balls, including that ball, and then it gets split up. The box with the tennis balls, the remaining tennis balls, and just that one ball. Okay, so we're going to write down the conservation of momentum in that direction. So instead, I've got M1 plus M2, its velocity, and then it gets split up. It gets split up to M1 V1. I'm going to say final, because the right side is usually final, plus M2 V2 final. All right, so there we have it. We did the conservation of inelastic. So this is called inelastic right here. One was elastic and this is inelastic. So they're together. They're together. Okay, so on this side here, This side here is initially, they're not moving, right? They're just standing still in the picture. Here's a better picture right here. They're all together, not moving at all. So I know that this initial velocity is 0. This whole velocity is 0. So that makes this whole side equal to 0. And what do we want? We want to know what V1 final is. We want to know what this one is. So if I've got conservation of momentum and this whole thing is 0, then I know that these two guys are 0. I've added up is going to be equal to 0. So let's see, I'm going to subtract this guy both sides. Let's subtract M2 V2 final to both sides. So I have a negative M2 V2 final is equal to M1 V1 final. All right, so I just want to solve for V1 final, so I'm going to divide both sides by M1. So my M1s cancel out, so now I can plug things in. I've got M2, I'm going to put here negative 0.057 kilograms times the velocity, which is plus 36 meters per second. And I divide that by the other mass, which is 55 kilograms. 55 kilograms. All right, so I divide those two together. Let's see, using my calculator, I'm going to have, let's see if you guys can see that, 0.057 times 36 divided by 55. There we go. And I end up with a negative 0.0373 meters per second because my kilograms here cancels out. Negative. Okay, so yes, I can now use scientific notation. Minus 0.373 meters per second. It's negative, which means it's to the left. Okay, so now you can understand the recoil of shooting a gun, why it makes you, pushes you back. You got a velocity going to the left side. Okay, again, this is an example of inelastic, but instead we put this stuff on the left side when the equation, you learn it, is the sum of the separate pieces added together and then combined on the right side. But it can be the other way as well. Okay, now I'm going to assume that 55 kilograms included everything, including the balls in there. All right, and that's it. So there we go. We just solved for the final velocity of that machine that spits out the tennis balls. See you next time.